Okay, so we're going to be looking at a, another way, start to see a pattern here, another way of finding delta H. And so the key word you guys are going to be looking for when you're doing these at this point is you're going to be looking for the word formation. Okay, so um, heat of formation, delta heat of formation, and if you're given data that looks like this, delta H sub F, then you're going to use this technique. And I will tell you that when you find these problems on my test on the IB exam, they are delta heat formation 99% of the time if you get delta H data. So bonds are different. Obviously, Hess's law is different, but if they give you delta H data, this is the technique you're going to use almost all the time. I'll show you the other technique, but it's not used much. Um, so so what is the definition here? And there's not a ton of space here, so I may have to write it in a different place because I don't have a ton of space here. So I'm doing a definition right here, but I think I'm gonna put it down here somewhere so I have some space to write. So there you go. I'll put the definition right there. Whoops. Let's do another. I'll do an arrow here so that you're like, oh, what's actually doing? There to there. All right. So here we go. Um, delta heat of formation, and there's a couple of important pieces here. So this is going to be enthalpy. Remember that weird word that also is like energy. This is going to be enthalpy change when 1 mole, that's important, when 1 mole of a compound is formed, there's that formation piece, is formed, and this is also important at its standard state. And so standard means like normal state of matter. And so you might want to just put in parentheses normal. So like water is normally a liquid. That is its standard state. Okay. And so that is what we'd be after, right? And then the 1 mole is important because when we make these things, we'll have to make sure there's 1 mole of chemical is what we're making because delta H is per mole. So, all right. So a couple more definitional things. What the heck is standard state? So standard state is going to be a pressure of 1 atmosphere, right? So like we're used to that as sort of standard conditions, and a fixed temperature, which means the temperature cannot change, which is ordinarily going to be 25 degrees Celsius, and then that's 25 to 73, right? So that's also going to be 298 Kelvin, and guys, that's room temperature, right? So that's room temperature. So that's kind of what it's telling you is like, what would a chemical be at a very normal pressure and at a very normal temperature. Okay, delta H values are either given in the problem, very common, or a table, or some of them are in the data booklet. There's not a lot in the data booklet because there are I mean, every single compound that exists has one, so they can't put them all in your data booklet. And so there's just a very few in there. Now, when you calculate delta H using these, it's very, very easy. You're going to add them up, and you're going to basically take products minus reactants. That's what you can do. You can add them up, products minus reactants. And so you don't have to do anything except do products minus reactants. And that's going to be a very common theme as we go through the rest of this unit. I will constantly be saying products minus reactants, etc. So it says it's the sum, meaning we're adding, of the standard enthalpies of formation of the products. And I'm going to Okay, so to pause it there for a minute, but what I was saying is that you're just going to constantly be doing products minus reactants. That's going to be sort of like the theme. And so it's going to be the sum of the standard enthalpies of formation of the product compounds minus the sum of the standard enthalpies of formation of the reactants, or the reactant compound is. So what does that boil down to? That boils down to add the numbers up for the products, add the numbers up for the reactants, and then it ends up being products minus reactants. Now, all of this stuff here, that just means sum, which means we're going to be adding. This means we multiply times the coefficient. So if you have like 3, you multiply by 3, 4, you multiply by 4, delta eta formation, and then the same thing over here. So don't worry a lot about that formula. If you if you want to make sure you're doing it right, you're just going to remember products minus reactants. And we're going to basically do that for the remainder of the formulas I'm going to teach you guys. Products minus reactants. Okay, so let's go ahead and look at this last thing on this page, and then we'll slide over and show you how easy these are. These are really easy. So delta H for elements in their standard state. This is super, super, super duper important. If you have an element and it's in its standard state, so like you have hydrogen, and hydrogen is a gas. So that's what hydrogen is, normal. So think about standard state. You want to think about normal. If you have an element that is listed normally, so hydrogen is normally a gas, then the standard state, or the delta H value, is going to be 0. They will also not always give you that. So they might give you a chart with a bunch of delta H's for a bunch of compounds, and you're like, well, where the heck is like hydrogen? Well, it's not there because it's 0. So they just won't give it to you. And that can be kind of tricky for students. They might get like super duper confused because they're like, well, I don't have enough information to solve this, but you do, because they assume that you know that delta H for regular elements by themselves that are in their normal state of matter is going to be 0. So let's slide over here. Let's take a look at these, and you'll see right away that we've got a chart, and that chart has delta H's. So what are we looking for? How do we know that we're going to use this particular problem-solving strategy? Is right here. They gave us delta H sub F. So delta H sub F, that is the big clue. So delta H sub F, that's the clue that we're looking for, that says that we're going to need to do products minus reactants. Now, everything is about the sign. keep the sign straight. If you do that, you're going to be in good shape. You get the sign confused, it'll be backwards. You'll have the answer, 55, but you'll have the negative 55 or whatever. So you get it wrong. Okay, now the balancing is super duper important because these 5s, this 3, and this 4, we're going to have to multiply by those. So we're going to do products minus reactants, and we're going to go from there. Okay, so we've identified what we're doing, and we're going to do our products minus our reactants. So that's something you have to kind of think through because you actually want to put these first. So they're the products, right? They're on the right side. So we're going to go 3 times the value of CO2, which is right here. So 3 times negative 393.5, okay, plus 4 times water. Now we got to pay attention because a lot of times there's different types of water. This one is liquid, but you got to watch out for like solids such as ice or vapor. So just be careful. Now there's only one here, so can't get too confused, but sometimes there's more than one if it's on a chart. So we're going to use that value there. So 4 times negative 285.8. So there are the products. We would add all those up, blah, 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 but then we're going to subtract them from the reactants. So then we're going to do the C3H8. So that would be 1, because there's only one of them, times the C3H8, and looks like that's right there, negative 103.8. Okay, and then we're going to add that to the oxygen. But see, the oxygen is an element, so it's a 0. And it's not just because it's an element, it's an element in its standard state. So let's go ahead and write that down, that O2 as a gas is an element in its standard or normal state. And what that means is it's a big 0. And so my delta H for that is 0. Okay, so then we go back up here. It would actually be, now I don't know if you want to do all this, but it'd be 5 times 0, which of course is 0. Now we're going to do the math on this thing. Now you got to be really, really careful because you're going to have all of these negative signs. You're going to have all of these ways that you can get yourself into trouble. And so just making sure that you do the math and get the sign right is really what we want to do. So let's go ahead and run it through. So it's going to be 3 times negative 393.5, enter. Add that to, in parentheses, 4 times negative 285.8, and hit enter. And then I'm going to subtract that from 1 times negative 103.8 plus, of course, 0, which is adding 0 is not going to do anything. But just be careful because I'm going to take my answer minus negative 103.8, which, of course, ends up adding it. So just be very careful with the signs. So I'm going to plug all that in, and I'm going to get an answer. Now, run it through. Don't just listen to me. Run it through. And then the answer I got, and this is the same answer you should get, is negative 2,200 19.9